So we'll see if this works. All right, so new unit today. Again, notes are thin, but dense, maybe, is one way to say it. All right, I shouldn't have written the first one out, but so we're taking a derivative of a triangle here. That seems weird. Why would we do that? But it's to emphasize the chain rule. Emphasizing the chain rule. In fact, let's just cover up the rest of these for now. The derivative of a natural log. Well, I just gave away the answer there. What's the derivative of a natural log? 1 over the argument times the derivative of the argument. Right? 1 over the argument times the derivative of the argument. If the argument happens to be a triangle, well, that's weird. We don't know what that means, but we can still follow the same pattern of 1 over a triangle times the derivative of a triangle. So what I want you to do is these next three are these triangle derivatives, these made-up things. And the point is, I guess, two things. It's a review of 3 different rules, but it's also a reminder to do the chain rule on each of these. So find some spot, I don't know if there's a spot, like top right of the notes even, to do those 3 fairly simple problems. Again, I gave you one to kind of work with and start with. So try those. That will be a good lead into what we're going to do today. Okay, Aslan, start us off. What's the derivative of a triangle cubed? How do you want to write the derivative of a triangle? Yeah, but you have 2 options. You can do d triangle dx. Triangle prime is definitely okay. It's what most of you prefer because it's shorter and easier. So that's certainly okay. Holly, how about the derivative of the sine of a triangle? Yep. Chain rule, chain rule, chain rule, chain rule. Caden, how about the derivative of e to a triangle?
E to the triangle times the derivative of the triangle.
Yes. Okay, I hope that was fairly straightforward, the emphasis being chain rule, chain rule, chain rule, chain rule on those. So let's jump to the notes now. See if we can make this connection here. So the first one, that's easy stuff, right? That's not anything new. In fact, let's just put James on the spot for all 3 pieces, James. If y equals 5x cubed plus 7x minus 10, then what's dy dx?
15x squared plus 7.
Yep. Good. Yes. Why am I shorting people notes today now? Okay. This next one is the whole point of today's lesson. Like, this is like, wait a minute. Can I still do dy dx if there's a y squared in my problem? So I want to take the derivative of y squared plus y and the derivative of x. All right, well, the right-hand side's easy, right? The derivative of x is 1. But think back to the triangle thing. What's the derivative? What do you think the derivative of y squared is? See if we just jump right in and get this. 2y is almost right, times y prime, because I need the derivative of y. So 2y times y prime, or dy dx. It's a chain rule thing. 2y times dy dx. What about the derivative of y? 1 y prime equals, and then the derivative of x would just be 1. So the rules are, there's not a new rule today, it's just there's some extra algebra involved, because now we're going to factor out the y prime. There's also, again, it just looks weird. You've done it before, but you've not done it with y's. Let's go ahead and finish this problem off. So y prime, I can factor out the y prime. 2y plus 1 equals 1. So y prime equals 1 over 2y plus 1. That is called implicit differentiation. implicit because, as opposed to explicit, in that first equation, y is explicitly solved for. Right? We have y equals something. That's explicit. We never use the phrase explicit differentiation. But when you don't have, when it's not solved for y, when an equation is not solved for y, then it's called implicit differentiation. The rules are still the same. The main thing people forget is throwing the y prime on the end of that. It's still the same rules, the derivative rules. You just have to remember to put the y prime whenever you take the derivative of a y. Okay, let's do some examples. Find the slope of the line tangent to the graph. Okay, again, we just like to use the fancy words for derivative. Y cubed equals 5x cubed in terms of x and y. So I want to take the derivative of both sides. Take the derivative of both sides. I'm not going to write that step every time because that gets a little bit like that's just what we're doing. You don't have to write that. But the first couple times I'll write it. Okay, right hand side, that's the easy side. So then what's the derivative of the right hand side?
15x squared.
15x squared. I'm a little hesitant to pull a popsicle stick yet for the left hand side. Anybody want to volunteer what the derivative of y cubed is, Seth?
3y times y prime.
Slow that down, what'd you say?
3y squared
Times y prime. Because the derivative of y cubed is 3y squared, but don't forget the y prime. And then to solve for, because it wants us to find y prime, so our calculus is over, but I need to get y prime by itself. So let's divide by 3y squared. And you could leave it like that. Obviously, a multiple choice would probably simplify. Again, no new rules, really, but remembering the chain rule when you've got y and maybe lots of y's thrown in there. Number 2, find the instantaneous rate of change of y with respect to x, meaning dy dx, if, and then this equation. So I'm going to take, this is the last time I'm going to do this, I'm going to take the derivative of both sides, so d dx of y cubed plus y squared minus 5y minus x squared equals the derivative of negative 4. Again, after this one, I'm not writing that step. You probably won't ever write that step again. But I don't want us to lose sight of the fact that that's what we're doing. All right, well, this looks like I can draw 5 popsicle sticks. So we'll just go one term at a time. If I can find 5 people who are present. All right, Ambria, start us off. What's the derivative of y cubed?
3y squared times y prime.
Good. 3y squared times y prime. Jace, how about the derivative of y squared?
2y times y prime.
2y times y prime. Justin, how about the derivative of negative 5y?
5y prime.
Yes. Well, minus, but yes.
Minus 5y prime.
Minus 5y prime. Jake, how about the derivative of negative x squared?
2x times x prime. Or no, x prime.
Okay, that's a great... I'm glad you said that. Because what you said, if this is the danger of writing it as prime as opposed to the dx stuff. So what you would have said is negative 2 dx dx. That's not wrong. What's dx dx? 1. So we don't really do chain rule on x's, although if you did, it wouldn't matter. So I wouldn't put dx dx, but you weren't really wrong to say it. Jimmy, how about the derivative of negative 4? 0. Again, that's supposed to be an easy one, but there's people who will get all the hard stuff right and then just leave negative 4 on the other side. Like, oh, so close, you did the hard stuff and you messed up the easy thing. All right, I need to do some algebra. See if I can do 2 steps at once here. I'm going to factor out the y prime. What do you think I should do with that 2x? Yeah, move that to the other side. So 2x on the other side. Y prime out front. So 3y squared plus 2y minus 5. And then I just need to divide by all of that stuff. So 2x over 3y squared plus 2y minus 5. Number 3. Find dy dx. Jameson, how about the derivative of tangent of x?
Secant squared x.
Yeah, secant squared. Secant squared of x. On the other side, I feel like there's some options here. Like if I take a derivative now, I will definitely have to use the product rule. If I distribute, I still have to use the product rule. So, do you want to distribute or not? It doesn't matter. I think I would distribute because I feel like it would be easier to keep up with. So I'm going to just write this as x plus x sine y. So I will still need the product rule when I get to x sine y. But at least that first part is, I think, easy. McKenna, the derivative of x? 1. And then product rule. But there's a y involved, so I wonder if I should slow this one down and not do that product rule in place, or I just do 1 times the derivative of the other plus the other way around. I think it might be wise to slow this one down. So I need an f prime and a g prime. The A team is more than capable of this. Addie, how about the derivative of x? 1. Addie got the easy one. Avery, how about the derivative of sine of y? Good. Cosine of y times y prime. Okay, so now I got to put this stuff together. Product rule, so 1 times derivative of the other plus the other way around. So I'll go, I'm going to put the y prime in front, so x y prime cosine y plus sine of y. Didn't plan ahead very well on this one. So there's my statement with the derivative in there. Now I just need to clean that up and get y prime by itself. So let's subtract the 1, subtract the sine of y. This would be where some of you are going to be ambitious with your algebra, which is fine, just be careful. So secant squared of x minus 1 minus sine of y equals all of this. What do I need to do to get y prime by itself? Because that's what I'm aiming for here. Divide by cosine y, I'd say that's half right. And x. Let's divide by x cosine y. So y prime is secant squared of x minus 1 minus sine of y over x cosine of y. May as well say it here. We get lots of weird answers when we're doing implicit differentiation. Again, the first row of derivatives isn't that hard, but then the algebra leads to lots of weird answers. Maybe I should say that. Algebra leads to lots of weird answers. So be careful. This is another one of those problems where sometimes the stamp is needed for students because they do that first line right. There's your calculus line, and then there's a couple of lines of algebra that you hopefully can get right as well. You ready to try one on your own? Why don't you try number 4? Let's see if I can do that. 9y squared y prime plus 8xy y prime minus 11y prime equals, now some of this stuff needs to go to the other side, 9 minus 4y squared minus 8x cubed. And then I'm going to show an extra algebra step that many of you won't. I'm going to show the y prime factored out. Some of you would kind of just do that in your head and divide by, all the not y prime stuff. 9y squared plus 8xy minus 11 equals, and I'm just going to attempt to be lazy. I'm going to not write that numerator again. Just 9 minus 4y squared minus 8x cubed all over 9y squared plus 8xy minus 11. Check my key from last year, see if I got the same thing. Yep. Okay. Lots of algebra. Again, no new calculus concepts, just making sure you remember to put that y prime in there. Number 5, find the slope of the line tangent to the graph, so derivative, at the point -1, -1. What makes this problem different than all the previous ones? At the point. So what does that add to the problem? Yeah, we'll solve by plugging in -1, -1 at the end, right? It just adds an extra step. Okay, the derivative of, this is a good triangle type problem here. The derivative of, I'm trying to cover up just that. The derivative of something cubed, so don't worry about what's on the inside. What's the derivative of something cubed? 3 something squared. So 3 something squared. But there's more to it. I need to do the derivative of the something. So what's the derivative of x plus y? Good, 1 plus y prime. So that left side got kind of ugly there. Right side, not too bad. So we can pick on 3 people for the 3 things on the right hand side there. Brooke, what's the derivative of x cubed? 3x squared. Autumn, the derivative of y cubed? 3y squared times y prime. And Lexi, the derivative of -6? 0. Again, that's supposed to be the easiest one, but so many times people forget to take the derivative of that constant and they leave that -6 out there. Ugh. Yuck. Algebra. Although there is an option here. On all the previous problems, we solve for y prime first, because that's the only thing we could do. This one, there's a little bit of a twist that we could do something different first. We could plug in first. So, I don't know. Math teachers would usually solve first, because that's what math people do. Students usually plug in first, because you're right, it does make things easier. So I think we should plug in first, and then we'll solve for y prime. Just be careful, don't plug anything in for y prime, because we don't know that yet. So 3 times negative 1 minus 1 squared times 1 plus y prime. 3 times negative 1 squared plus 3 times negative 1 squared y prime. So I don't know, is that easier? Maybe. Maybe not. Square of negative 2 is 4, times 3 is 12. On the other side, 3 plus 3y prime. I mean, you're still doing all the same algebra steps. It's just, would you rather do it with numbers or letters? Most of you would probably say numbers. I'm going to distribute to 12. Now I'm getting close, finally. Let's move the y prime to the left. Move this 12 to the right. And y prime equals negative 1. And I guess like most of today's steps or problems, there's one calculus step and then what, like 4 or 5 algebra steps. And obviously you got to do them all correct to get there. Oh, number 6. You can just put a star by number 6. Just feel like it shows up on the test every year. So just may as well know it now. Find the second derivative in terms of x and y. Oh, second derivative. Again, there is no shortcut to the second derivative. I wish there was. Students wish there was. You have to find the first derivative and then find the second derivative. So let's pick on 3 people here. Make it through everybody today. Dylan, how about the derivative of x squared? 2x. Ashlyn, the derivative of y squared?
2y.
Good. 2y, y prime. And Austin, the derivative of 36? 0. Okay, so negative 2y, y prime equals negative 2x. So y prime equals x over y. That's not bad. You okay with that? Divide by negative 2y, the negative 2's cancel. So we got y prime. But that's not what we want. That's the first derivative. And don't forget, we keep using y prime instead of dy dx because it's easier, but don't forget that those are the same thing. So now I need a second derivative. I'm going to show this step, even though I don't know that most of you would. So I want to take the derivative again. What would that give me on the left-hand side? What's the derivative of y prime? Yeah, y double prime, the second derivative. And that's what we want. So we're well on our way here, or at least so it appears. Foreshadowing of work to come. What will it take to do the derivative of the right-hand side? Quotient rule. So like note to self, gf prime minus fg prime over g squared. Okay, so gf prime. So the bottom times the derivative of the top minus the top times the derivative of the bottom. What's the derivative of y? Y prime. All over the bottom squared. Okay, so in some sense we're done. Like we've got the second derivative, and we've got the second derivative like solved for. It's not buried in one long equation where we'll have to do some algebra. But do you know why this answer is not what's being asked for? Yeah, in terms of x and y, and there's a y prime sitting in there. So we have solved for the second derivative, but we have not got it in terms of x and y because there's a y prime. Plug in what? Right, we have an expression for y prime though. So in place of y prime, I'm going to put x over y. So y double prime equals, clean this up a little bit, so that would just be y minus x times x over y squared. That would be a safe stop. But what if it's a multiple choice question? We don't like fractions and fractions. Multiply what by y? Top and bottom by y. That will clear that y out of there. So I'm going to multiply top and bottom by y to clear the y out. So second derivative is y squared minus x squared, right? Because the y is canceled. That's why we did this. And in the bottom is y cubed. It's one of those where it was a long problem, so I'm going to check my answer to make sure it looks good. Y squared minus x squared over y cubed. Okay, we answered the question, but if it was multiple choice, glad I checked the multiple choice answers. Maybe this will make sense when you see some answers here. It's one of those. That can make up some other bad answer choices, but the others would be answer choices where if you messed up the original problem. Yeah. So if this was just you would stop there. Like there's no reason to go any further. But you look at those answer choices, you're like, wait a minute, 36, where did that come from? Brooke, where did 36 come from? X squared minus y squared is 36. Although I've got y squared minus x squared. So that means y squared minus x squared equals negative 36. So I can replace that numerator with negative 36. Well, if it was a free response question, you'd have stopped way back here. But there are questions like that on the homework because there are questions like that on the test. Again, on your own, you would have stopped here. Maybe you felt ambitious and cleaned it up to here. Then you look at your answer choices, and hopefully you're like, 36? What? And hopefully that would jog your memory, like, wait a minute, something's going on in this problem, and you could figure out whether it's positive or negative. Number 7. Again, a lot of notes today, but no notes on Monday. It'll just be answering questions. A spherical balloon is being inflated. Write an expression for the instantaneous rate of change of the volume with respect to time. That's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 16 words to say what are we looking for? Derivative of what? Derivative of volume with respect to time. Well, that's a lot of words to say dv dt. That's what we're looking for. And they were kind enough to give us a volume expression. 4/3 pi r cubed. All right, if I want dv dt to show up, what derivative should I take? It's different than all the other derivatives we've taken today. I need to take a derivative with respect to, if I want dt in the bottom, I'll need to take derivative with respect to time. So it's, again, all the same rules. This one just looks different because there's a t in the bottom instead of an x. Well, the left-hand side's pretty easy, dv dt. What about the derivative of 4/3 pi r cubed? Multiply by 3. Reduce the power by 1. There's your most common wrong answer right there. 4 pi r squared. Because like you didn't do anything wrong per se, but what am I missing? The 3 and the 3 canceled. That's where that went.
R prime?
R prime. Or, let's be more specific. This is the only drawback of the prime is it's not clear what derivative you're taking it with respect to. So I'm going to do dr dt. Usually we save the primes for with respect to x. I don't know that r prime would be wrong, it just wouldn't be as clear. Number 8, and final. Water is draining out of an inverted cone. So like an upside down cone. Write an expression for the rate of change of the volume of the water with respect to time t. So again, we're looking for dv dt. Volume of a, whoops, that should not say sphere, that should say cone.
Wait, it says rate of change, not instantaneous.
Good catch. If it doesn't say average though. If it doesn't say either one, we assume instantaneous.
Okay.
If it doesn't say either one, we assume instantaneous. Good catch though. So 1/3 pi r squared h. So again, I'll need to take a derivative with respect to time of both sides. Left-hand side's easy. That's dv dt. That's what we wanted. What about the right-hand side? How many variables are in the right-hand side? 2. And they're being multiplied. Therefore, how do I take the derivative of things that are being multiplied? Product rule. You could put the 1/3 pi like just all the way out front. I think it's easier to like just attach it to whatever it's close to, and then there's your f and your v. So first times derivative of the second, 1/3 pi r squared. What's the derivative of h? Don't overthink this.
1 dh over dt.
1 dh dt, or just dh dt. Again, h prime is dh dt would be a better way to say that. That's how h is changing with respect to time. Plus the other way around, so h times, okay, this one's a little bit trickier. Luke, I think I've only got you left here. What's the derivative of 1/3 pi r squared? You can kind of leave the 1/3 pi alone.
Yeah.
What's the derivative of r squared?
2r times r prime. Oh wait, no.
R prime is right, but I'd rather you say R prime isn't wrong, but I'd rather you write it as something with respect.
Oh, I'm blanking.
Dr dt. Again, R prime, I don't think anyone would mark it wrong. Dr dt is much better, much more clear. Especially when we get to word problems, we're going to say things like the rate of change of the radius is 2 centimeters per second. So that's dr dt. And I don't know if there's any cleanup to do on that. And you could write that a little bit better, I guess. Addie, is that a question or a stretch?
Oh, I was just
Okay. Seth?
On a multiple choice, would like the dh over dt dt dr over dt, could that be d squared hr, or do those terms be combined at all? Like,
Nothing can be combined here,
okay.
other than maybe writing this a little bit cleaner, like 2/3 pi RH dr dt, just sort of rearranging the order, but there's nothing that can be combined or even factored out, because I guess you can factor out a 1/3 pi, that's the only thing.
So with respect to like the dB, dt, dr dt, the dr dt comes when you're dealing with the radius, and the dB comes when you're dealing with the length.
Correct.
Does that say dh, like after the 1/3 pi, the top?
That says
Numerator?
that says dH dt,
So
yes.
that the h comes from the...
Because we did the derivative, we did first
Oh.
times derivative of the second. And then we did second times derivative of the first.
Okay.
Okay, worksheet 1, I'll say today's assignment is 1 through 10. And then that's Friday's assignment. Monday's assignment will be 11 through 19. So no new notes on Monday. I'll just answer questions from 1 through 10 and work a few of 11 through 19. So you can kind of figure out